we are going to continue with the polymers file, how the polymers are going to form from simple monomers. What are two different types of the polymers, addition, condensation, and different examples of polymers as well. First of all, what is polymer and what is monomer? Monomer means the small unit which can combine together and they can make some bigger polymers. Small unit of anything, it can be any organic compound, it can be amino acids in biology, or any small things which can combine together by covalent bonding and they can make bigger polymer or bigger chains. Okay, so that small unit will be known as monomer, which is going to repeat again and again. And the big unit, which is going to form at the end, will be known as a polymer. And this reaction, which is making the polymers, will be known as polymerization reaction. Okay. So for definition, polymers can be large molecules in which 50 or more smaller molecules can combine together by the help of covalent bonds and make bigger polymers. Some simple examples of the polymers are PVC, plastic, and nylon. We will talk about these two in detail. So all the plastics basically that we use, that is formed by this polymerization reaction from the small monomers. Proteins in our body is one of the example of the polymers, which is made from amino acids. So we will talk about these examples in detail. Okay, how they can form basically. Let's talk about any monomer. This ethene over here is one of the monomer. It means many ethenes can combine together and make the polymer. This is polymer over here. As they said, we can take 50 or more than 50 monomers as well. It can be 100, it can be 1000, which can combine together. So let's say we have this ethene, any number. So whatever is the number which is going to combine together should be written at the start in place of this n. N means the number. Let's say you are going to combine 50 of the ethene together to make a bigger polymer. So you will write the ethene formula with the number at the start over here. Okay. Then what will happen? One ethene will combine with the second one, second with the third one. So they're going to make a long chain of 50 ethene molecules together. Okay. So there is a short form to show this because if we are going to make this on a paper, 50 ethene together, it will take a lot of space and a lot of time as well. So we can just make a short form of this ethene. We can tell how it is going to just repeat again, and again, how many times. So I will tell you how to write this repeating unit and the polymer formation. Okay. So to make this, we have basically, we'll come back to this example, how to write this. We have basically two different types of the polymers. The first one is addition polymer. In addition polymer, there are some conditions that what type of the monomer we can take to make addition polymer at the end. Okay. So the monomer that we are taking in addition polymer should always have a carbon-carbon double bond. The monomer should have a carbon-carbon double bond. For example, ethene. Ethene is having carbon-carbon double bond. When ethenes are going to join together, they are going to make addition polymer at the end because they have carbon-carbon double bond. Okay. So when these ethene molecules have to join them together, they will join with each other by breaking the carbon-carbon double bond. Okay. How? Let me just show you this example again. We said that this ethene is a monomer which can join together to make a polymer. So take one ethene molecule. Okay. This is one ethene. Write it as it is, like it is given to you. Then take an other ethene molecule which you want to join with it. Okay. This way you can take as many as you want, second, third, fourth, that you want to join. Okay. Now how they are going to join together? For this, rule number one, you have to break the carbon-carbon double bond. Okay, so remove double bond from this one, remove double bond from this one, make it single. This is rule number one. Rule number two is you have to extend single bonds from both the carbons. Like this carbon is going to extend the single bond to this side so that it can attach with something new. This is going to extend the bond to this side. This carbon is extending the bond to this side and combining with this one. This is extending the bond to this side. So every double bond which is going to break will extend the single bond on both sides. And then they will connect with each other. Okay. So same way they can have one more monomer over here connected, the fourth one, the fifth one, like this. So they will keep on repeating the same thing, breaking double bond, making the single extended bonds on both sides, joining them together, and that's it. That's how they will make long, long chains over here. Okay. But if you keep on doing this, let's say I'm going to make the third one over here, which was carbon-carbon double, but it will break into single when it will join with it, and then it will extend the bond as well. So it will extend the bond over here, and then it can combine with the fourth one, fifth one, like this. Okay. I can keep on adding this, and it can go up to 50 units, 100 units, 1000 units. So it will not be easy for me to make this long chain over here. Okay, so for this, I will tell you how to write this in a short way. Okay, so we have some questions over here. Yes, Luna.
Miss, if I wanted to join, for example, I wanted to join two Athenians together.
Hmm.
I break the double bonds. Okay, I made, Miss, the one you made in the first place. Will the end? Okay, I have two empty you can say empty connections. I do not have any other atom to connect with it. Do I can connect it with a hydrogen?
Yes,
Like,
when it
will
will be
it?
the final one, let's say your polymer has just these three units. Now you want to just end the structure. Then it will
Yeah,
be the hydrogen on both sides and
yeah.
it will end.
I was about to ask if it will change the structure or the formula or anything, or
Yes,
it
yes.
will be the
Because
same.
when it is going to change into the polymer, it is now an alkane, single bonded one. So you can see all the carbon-carbon single bonds are there at the end. So now alkene, ethene is changing into alkane when it is making a polymer. So we will just add the hydrogens when it will end, as many monomers as you want to connect them, and then add hydrogen on both sides and that's it. Structure will be done. Okay. Yes, Varif.
Miss, my question is it better if it was like double bond or like one bond, but it's like separated?
Double bond, again, your question is?
Miss, so the polymers like to separate the double bond and make a single bond, right? So, Miss,
Hmm.
it's better if it was double bond or like single bond but separated.
So they will break the double bond to change this into single. Okay.
Yes,
And then they will just make extra singles on both sides. Why they are
yes,
making extra single on both sides? Because every carbon needs to make total four bonds. When we are breaking the double, this carbon right now over here has four bonds. It has two on this side, one here, total four bonds. When we are breaking the double, means now both the carbons have total three bonds only. They will make again four. So they will make the fourth one on the sides to make it
yes,
again total four bonds.
yes, Miss, I got it. But like, Miss,
Hmm.
then if it's better if it was like as a double bond as in the first one, or like as the down one, like single bond, but like it's four, like
Yes,
from
yes,
each side.
it's better as well. You can write it anyway.
Oh, okay.
It is just to
Thank you.
give you an idea. There is no need to like draw the double again and again and then remove it. And you can just keep on connecting them. If you got the concept, no need to make the double, just keep on connecting them with the single.
Miss, so
Okay.
basically, polymers are always single bonded.
All the polymers will be single bonded. When they will
Okay.
start from the monomer, they will have double bond. But when they will keep on connecting, every monomer has to break the double bond to connect. So means at the end, they will not be alkene now. They will not have double bond. At the end, it will change into simple alkane. Okay. So now, if we don't want to end it till the three monomers, we may have, let's say, 50 of the monomers connecting together. On an exam paper or any paper, you cannot make a long chain of 50 monomers together to make a polymer. It will take a lot of time. So what you can do, you can just make it one time, okay? And then, okay, let me just remove the other three. We can just make it one time and then break the double bond, extend the single bonds on both sides till here, and then just add a bracket, a square bracket on both sides, and put the same number n. Let's say your n number is 50. We will put the number 50 over here to the bottom side of the right of the bracket. It means this part inside the bracket will keep on adding 50 times to make a polymer. Okay. Why we cannot just write this double bonded and say it is 50 times? Because double bonded one is not coming 50 times. Double bonded one is breaking the bond, joining with the single on both sides, and then that part is keep on repeating 50 times. So when you are making the bracket should be square bracket, very careful. Plus one more thing. This bond that is single, which is extended on both sides, it should come outside the bracket. Okay, it should not stay in the bracket. It has to cut and come outside the bracket from this side, outside the bracket from this side. It means this thing is continue on both sides. Okay, yes, Jodh.
So, Miss, for polymers, it should only be 50 or more linked together, or it can be less than 50.
It can be less than 50 as well. It is possible, but maximum of the polymers or plastic we use, they have at least 50. Okay, they are bigger. They are like having more than thousands of monomers together. But even if you join few of them, 3, 4, 5, 7, it is still a polymer. But
Yes.
most examples that we use the plastics, they have 50 or more than 50 connected together. Yes, Samri.
Is in the exam they will give us the number of monomers.
They will give you the number of monomer. How the question can come in the exam? Maybe they can give you ethene and they can ask you how the polymer will look like. Then you will just make this polymer in the bracket and write the same number outside. Okay.
So Miss, the number is n or any number for ethene.
It can be any number here. If they have not given you the number, then just write n. And
Oh,
if the
okay.
number is given, then write that number. It can be 50 here, it can be 100 here. Nothing is given, just write n here and n outside the bracket as well. Okay?
Okay.
And when we are going to name it, naming of polymer is very easy and important. Whatever is the monomer. As I told you that alkene will change into alkane at the end, like just single bonds. But the name is not alkane. Okay? Whatever is the monomer, write the same name in the bracket. And outside the bracket, you will write the word poly. That's it. Poly bracket ethene. Let's say your monomer is propene. So you will just write polypropene. So monomer can be anything over here having double bond. Like in place of these hydrogens, it can be anything. Let's say I have a monomer which has carbon-carbon double bond. It has CH3 attached over here. Okay. Another CH3 is attached here. It has chlorine over here, fluorine over here. No problem. We are just concerned with the carbon-carbon double bond. If double bond is there, yes, it can make a polymer at the end. Okay. So this one will have a long name. It will be 1-chloro, 2-fluoro, 1,2-dimethyl propene, ethene. This will not come, this type of the names will not come in the exam, just an example. If all the groups attached are somehow different or any groups are attached, no problem. You're just concerned with the double bond. If you want to make its monomer, just break the double into single, extend the lines, put the same groups attached above, attached below, whatever is number at the start, put the bracket which is cutting the side bonds and put the number outside. That is going to be your polymer. So whatever will be the name given for the monomer, write that name in the bracket. Outside, write poly word. That is going to be your polymer. So anything can be attached over here. It can be any ring attached over here. No problem. In place of the chlorine, let's say they have attached a ring over here. So no need to change this ring. The same will just connect inside. You have to just see the double bond. Attachment can be anything, just attach everything, whatever is given. A ring structure, a simple structure, anything attached, just write all the attachments same to same. Just the central double bond you will break into single. That's it. Extend the lines, put the bracket outside, put the same number outside the bracket. Okay? Yes, Amreen.
Miss, what's a ring structure?
This ring basically is carbon-carbon ring together. Let me just, it was just an example. Let's say you have these 6 carbons ring, which have any double single bonds connected together. Same can be given as well. Whatever is given, just you are going to make the same thing. Because alkane or alkenes can have the ring structure as well. They can have the straight structures as well, branching. Whatever is given to you, you are going to just make the same thing attachment.
So, Miss, a ring structure doesn't really affect the name of the polymer, right?
The ring structure will affect the name, but the name will be given to you. Whatever is the monomer name given, that name you will put in the bracket, put poly outside. Okay,
Okay.
let's see some simple example. Ignore the ring. It's just an idea. Whatever complicated monomer is given, you don't need to name it. You don't need to identify what type of the structure is this. You just need to identify double bond, break it, make the polymer. Add everything, whatever is attached on it. Okay. Now, this is monomer when it has double bond. This is polymer when it will be having single bond and bracket. There is one more thing which is called repeating unit. 3 types of the question will come in your exam. They will ask you what is a monomer, what is a repeating unit, and what is a polymer. 3 things total. Repeating unit means the unit which is going to repeat again. So the unit which is inside the bracket is repeating again and again. So for this monomer, the repeating unit is this one without bracket. So you will say that C bond C attached with 4 hydrogens above and below with single bonds on both sides. This is a repeating unit. For the repeating unit and polymer, how they are different, repeating unit will not have a bracket outside and repeating unit will not have the number written. If you take this unit, which is a repeating unit, put the bracket outside and n, then it will become polymer. If you remove the bracket and number n, it will become repeating unit. And if you add the double bond back, it will become monomer. That's how these 3 are different. So just, I will explain it again. Monomer will have the double bond, break the double bond into single, extend the lines, but don't put the bracket. Then it is repeating unit. Then if you put the bracket and number n as well, then it will become polymer. Okay, this is clear to everyone. Any question till here? No questions?
Miss, if you repeated the repeating unit, the difference between polymers, and you repeated units again, please?
Yes. For the repeating unit, it is the unit which is coming again and again. So we'll say this part which is inside the bracket is coming again and again in the polymer structure. So this part is going to be the repeating unit. So repeating unit will not have a square bracket and the number outside. If you put the square bracket and the number n outside, then it will become a polymer. Okay, because polymer is telling how many times it has this unit. But the repeating unit is just telling that this unit is repeating many times. Okay, so that's how they are going to be different from each other. So let's move to some more examples to identify the monomer, polymer, repeating unit. So all the summary, everything is given over here. That for addition polymers, yes, Luna.
So basically, an repeating unit is a part of a polymer.
Repeating
So
unit
like
is a
it's
part
the
of polymer. Yes.
so
Repeating
it's a
unit,
main structure.
that which part in the polymer is repeating again and again. So it's the part of the polymer. Okay.
Okay, thank you, Miss.
Okay, so all the conditions that we just discussed is given over here. that they should have carbon-carbon double bond to start. They will break the double bond, then they will extend the single bonds on both sides, and then they are going to just attach together by covalent bonds. So when we are writing the name, we are going to add the word prefix poly at the start, and the main name should be written in the bracket. Let's say your monomer is propene. So you will write polypropene. Your monomer is ethene. You will write poly in the bracket ethene. So that's how you will just name your polymer. Okay, how you can identify the polymer from the monomer? This is one type of the question in which they can give you starting monomer and they can ask you, let's say this is not given to you. They can just give you this equation that, okay, you have ethene or you have chloroethene. You are going to write this polymer over here. This will be empty, blank. They will ask you that you have these two monomers given to you. Make the polymer by yourself. Polymer, not repeating unit. I'm saying polymer. Polymer means in the bracket. So what you will just do, break the double bonds. Okay. Add the single bonds on both sides. Put the square bracket number n. All the attachments will come as it is. This is simple ethene. This one has chlorine attached at the top, so it is chloroethene. Name is already given to you. No need to get worried about the name. It will be given. Write the same name in the bracket chloroethene, put poly outside. Okay, so this is how to write polymer from the given monomer. Then another type of the question can come in which they can ask you to identify monomer from the polymer. Like polymer is given, make the monomer. Okay, yes, Mariam.
Miss, I still can't understand. يعني if we break the double bond, so they will make bond again with with what?
Yeah, we will break the double bond from the center and then they're going to make the bonds on sides. By breaking the central bond, they're making the new bonds on both sides. So we will break from the center double and add extra bond 1 on both sides. Same we have to
So
do.
they will make bonds with them.
Yes, so they will all link together with these new bonds. So these new bonds are telling us about the attachment, how they are going to link together. Okay?
Yes, thank you so much.
No problem. Okay, now how to see, how to deduce the structure of monomer if the polymer is given to you? Like if this polymer is given, how you can go back to the monomer? Any idea? Let's say for this example, they have given you this product. They have given you this polymer and they have not given you this monomer. Can we just make this monomer by ourselves if this polymer is given?
Yes, miss, put double bond.
Umama, yes.
We'll just miss put the double bond out there.
Put the double bond. What about the side bonds, bracket, everything?
We will,
Okay.
will just
Mm-hmm.
miss
Yes,
remove it.
just remove it. Okay, that's fine. Yes, Samreen, what's your point of view? How we can go back to the monomer?
Miss, we can remove these brackets and add a double bond and remove the side bonds also.
Okay. Okay, yes, Jude.
Yes, miss, the same thing. Just remove the brackets and the side bonds because we already put the double bonds, so the side bonds aren't needed. So we'll just remove them.
What about the number n, where it will go?
The
Yes, Jude.
carbon.
What about this number n, where this number will go?
Will we write it or no? I'm confused.
No, we will write it. We will write the same number n at the start now when we write.
Ah,
Okay. So number n will come at the start. So yes, your point of view is correct. We are going to put the double bond back. When we are putting the double bond back means the side bonds we have to remove, which we have added before. And then we can remove the square bracket as well. And this number n, which was written outside, it will come at the start. Most of the time, this number will not be given to you. So write n. Writing n is a must thing. If number is not given, then just write n. That there is n outside the bracket and n at the start of the monomer. Okay, so this is must thing to write. So yes, same thing is given to you. Let's say this is one of the polymer given without bracket. Polymer can be given to you with bracket. Polymer can be given to you without bracket. Let's say this is one of the polymer given. Your first thing is to identify what is the repeat unit. In this structure, if you see, repeat unit will always have two carbons, first of all. You can see this carbon with two hydrogen, this carbon with one hydrogen and chlorine. Okay, this thing is coming one time. Then this is coming two times. Then this is coming three times and four times. So it means there are basically total 4 monomers in this part. Okay. Then take any part. From these 4, you can take maybe first, second, third, last, any of your choice. No problem. Let's say they are taking the last one. Okay. Take the last one and put the bracket as your rough work. That this is basically the part which has to repeat again and again. It can be first, second, third, any part you can say. That this part in the bracket is basically just repeating 4 times over here. Now again, just take this part, put the double bond at the center and remove the side bonds. That is going to be your monomer. No need to write it 4 times. For your convenience, they have written basically that there are total 4 monomers which are connected. But we can just write it one time and we can write the number 4 at the start. That this monomer is coming 4 times to make this polymer. This is clear? And this is simple chloroethene, which was making the polymer polychloroethene. You can even get the name. If the name polychloroethene is given to you, now remove the poly word. Just write chloroethene as the monomer name. Yes, Luna.
Miss, will it differ if I just, for example, if I switch the places of the chlorine with the above hydrogen? If I
No
switch them,
problem. You can switch the chlorine position. It can go above or below, no problem. But don't put it on the first carbon. It will remain on the same carbon, but you can write up and below, no problem for the position for now.
oh, so if I put it in the first one, it will change.
For now, it will not change because it's just one chlorine. But let's say the first one has fluorine, the second one has chlorine. Then you have to be careful. Then you cannot put both on the, let's say you have a monomer having double bond, having fluorine over here,
Yes.
chlorine over here, and 2 hydrogens. In that case, you have to write this way. In that case, you cannot take this chlorine and put it on this place. Because
Oh,
chlorine...
no. Yes, Miss. For example, if I change the
Mhm.
chlorine and the hydrogen of the new example that you have made, the chlorine and hydrogen.
Fine. It cannot go to this hydrogen, but this chlorine can go to this place. Same, no problem for now. It
Okay.
will have a problem in for your higher grades. In grade 11, you will see that they cannot go even above and below. For now, if you change the place, no problem. But it's better to write it in the same way so that you don't get confused.
Okay.
Yes, Samri.
Miss, a monomer has a double bond or a single bond?
Double bond. Monomer should have a double bond. Repeating unit will have single bond, and polymer should have single bond.
So, Miss, a monomer has a double bond, and a repeating unit will have a single bond.
And polymer should also have single.
Okay, Miss.
Okay. So that's all about the addition polymerization. After the addition polymerization, we have condensation polymerization, the other type of polymerization. This is completely different from addition. Now, as we said in the addition, we need carbon-carbon double bond in monomer. Only then we can proceed to make polymer, right? That was the condition in case of the addition polymerization. In condensation, this condition we don't need. We don't need any carbon-carbon double bond. There is no need of carbon-carbon double bond. Okay. If carbon-carbon double bond is there, then it should be addition polymerization. No carbon-carbon double bond means now it is going to be condensation polymerization. Then what we need for condensation? What is the condition? In condensation, basically, 2 different monomers can connect together. Let's say I have a carbon. It has, let's say I have a structure having 2 carbons. It has OH functional group on this side and other OH functional group on this side. Okay. Let me just give you an example, then I will tell you how to make it. This is one of the monomer. Let's take another monomer. I have two carbons having hydrogens at top and below. It has carboxyl COOH, carboxylic acid functional group, and another carboxylic acid functional group. Wait, no questions for now. Let me just explain first. If you will ask question in between, you will get confused. Okay. So this is first monomer. This is the second monomer. Okay. Condensation polymer said that you are going to have two different monomers. Both the monomers should have two functional groups on both sides. Only then they can combine together to make a condensation polymer. For example, this is the monomer number 1. It has two different functional groups. It has two functional groups, OH on this side as well and OH on other side as well, right? It has two OH groups, alcohol groups. Then I have the second monomer, monomer number 2. It is also having functional groups, means COOH and COOH on both sides. So yes, it is also a good monomer now. Now these two monomers can combine together and they can make condensation polymer. So this is the condition. We don't need double bond, nothing else. We just need the functional groups for every monomer and it should have two functional groups on both sides. Only then it is going to make a polymer. It can be like C bond C having hydrogens. It can be not only two carbons, many carbons. It can be 3 carbon, 4 carbon, whatever is the carbon number, just write it. But the side bonds should have functional group. It can have NH2 functional group over here. NH2 is also one of the functional group. It has NH2 functional group over here. This is also one of the monomer number 3. So monomer number 1 and 2 can combine together, or maybe monomer number 2 or 3 is combining together, maybe 1 or 3 is combining together. So any two monomers having the functional groups on both sides can combine together to make condensation polymer. Now your question, then I will explain you how they can combine together. Yes. Luna.
Miss, didn't we say that monomers are usually double bounded?
For addition polymerization.
Oh, so it differs.
Other type of polymerization. For addition polymers, they are always carbon-carbon double bonded. For condensation polymers, they don't need double bond, but they need functional groups now on both sides. Okay. Now let's see
Okay,
how
Miss, so
to combine.
basically,
Yes,
so basically,
Luna.
one of them is, if I can remember, one of them is carboxylic acid, right?
One of them is
And
carboxylic acid, let's say. Other can be
and
alcohol.
one of them is alcohol, right?
Yes.
Something like that.
Something like
Okay.
that. So they can be any other example. It's not only these three polymers, there are many more examples. Let's check out if we have, let's say, alcohol one and carboxylic acid one. What will happen? So nylon is one of the condensation polymer. It is formed when we have carboxylic acid polymer and when we have NH2 polymer, this one. Okay, let me show you the structure. Okay, this is this is the first monomer, this red box, and this red box is the second monomer. If I show you where is the functional group, you can check out this blue one. This is COOH, carboxyl, right? On other side, this is also COOH, carboxyl. So this is carboxylic acid functional group for this first monomer. And it has 2 carbons at the center and 2 attached on the sides as well. Okay. Then if you check out this second monomer, it has NH2 over here, NH2 over here. When they have NH2, we say them amine. It's amine functional group. And when we have COOH, we say it carboxylic acid functional group. This carboxylic acid we did already. And this is going to be amine functional group. Now what will happen? These two have to connect together to make a condensation polymer. how they are going to connect together. They both have to release some small molecule to make a bond with each other.